primarily this equation right here and this one here are defined as follows. In the formula for finding the future value of a sum of money with a compound interest, okay, the mathematical expression, is what we're looking for, is 1 plus the interest rate and brought to n number of periods, right? That's what we have. So this is a good one. It's in your book, and also it's good to memorize this one as you'll be using this often. So that's the future value of money. Okay, that's how you would use that. However, the factor tables in your handbook use this shorthand as it's being called, and this would then be the future value given the present. Okay, so calculate given is basically what we're going to be doing. And instead of using this equation, we're going to use the factor table. So those are the numbers that are already multiplied. Where do all those numbers come from? The equations for what we're going to be exploring next. Okay, so effectively what the factor tables do is they shorten your time in going through detailed calculations, and let's continue to explore this. The concepts that you need to make sure that you have and understand are the following. This is the present worth. When we looked at our cash flow diagram, we made an evaluation on day 0, right, over the amount of periods. And so when we're looking at present worth, we identify that with the letter P, and it's at time is equal to 0. Okay, make sure that that's clear in your mind that we're looking at 0, very similar to that 0 position. So there it is. And then each of the periods that we're going to get. So if you're accumulating interest, okay, if you're accumulating interest, you're getting the interest at the end of each of these years, okay? And so that's effectively what we're doing here. And so remembering what we reviewed at the very, very beginning that we introduced, the very first few pages, that's our present worth. Discounting is the inverse of compounding, and it's determined as a present amount which with a yield that's specific to its future sum. We're going to go through these as examples. Okay, we're learning the abstract, the words that we're going to be using for this, and so be familiar with these words. The next is the annual amount. It's the uniform amount that repeats at the end of each year, okay, for n years. And our last concept here is a generalization for what you need to know from your engineering economics is a gradient amount. And so what is that gradient amount? Well, we're able to project out in a linear format a gradient. Okay, and so what we already know using the Cartesian coordinate system, if we have dollars associated here, time in our x-axis, dollars in our y-axis, well, at any point in time, we're seeing that there's an incline or an increase on a per year basis or a per time period basis, and that's a linear approach. So we have a gradient amount, which we'll be able to calculate what happens with this gradient amount with the time feature associated with this. Right, so here's your gradient. Once again, we're transferring all the learning that you already have. Cartesian coordinate system. You know how to calculate the slope of a line. All of these are all interpretive and brought to engineering economics. We're using the same mathematical principles as you use in general math.